The federal approach, the federal Class VI program, by its nature, is a one-size-fits-all program. It's often inefficient and inflexible. They don't consider state-specific considerations, concerns, conditions, regional variability. They just don't account for it. And they don't account for pore space ownership, nor do they account for a mechanism to release liability after closure of a facility. They do not have that option. And so the state pursued primacy with the intent of resolving some of those, as well as developing a different regulatory framework. So the regulatory framework that the state has implemented, and I'll get into those in a little bit, but we solved some of those problems, and then we have an option. We know who owns the pore space, and we have the option to amalgamate that or group that for the purposes of an injection project. And we also have a release of long-term liability after the closure of a facility. The process that North Dakota took really starts in 2007, actually probably before that, but with North Dakota's involvement in the IOGCC, or the Interstate Oil and Gas Compact Commission's Carbon Capture and Geologic Storage Task Force. In 2010, we actually promulgated our first rules for geologic storage. Before the EPA finalized its Class VI rules. And then in 2011, unfortunately, the EPA became the acting regulatory authority over all states, including North Dakota. So we went back to the drawing board, revised our rules, amended our rules, and in 2013, we issued our new rules and applied for Class VI primacy. The authority to regulate our own program instead of have the federal oversight. And so we put that application in 2013, and we finally received approval April 24th of 2018. We received our Class VI primacy. As I indicated, why we applied for primacy, we have a fundamental difference in the way we look at regulating CO2 sequestration, carbon dioxide sequestration versus the way the federal government does. We look at it from a resource management philosophy versus their waste disposal philosophy. And what does that mean? Really, the major differences are we look at CO2 and it's considered a commodity, not a pure waste product. We consider the pore space itself to be a resource, and the federal program doesn't even consider pore space ownership in any way, nor compensation for its use. And so another function here is that we look at it on a risk-based, we take a risk-based approach to regulating these, enforcing and inspecting Class VI storage facilities, whereas the federal approach is more rigorous style. It's reactive, typical environmental oversight from the federal side. Again, a key here is that we consider that CO2 a commodity. What that does is it allows the different energy sectors, coal, gas, ethanol, to come together, work with the regulatory body to come up with projects and storage projects that make sense for our state and allow us to get through the whole process and actually start sequestering carbon in North Dakota, whereas the federal program is purely its disposers, producers and disposers of CO2 working together, trying to get a waste product gone. I touched on the regulatory framework that we established when we pursued primacy. But there's a couple key points in developing that regulatory framework and establishing new rules and regulations. You need to go for two key things. You have to have regulatory certainty. Without regulatory certainty, industry just can't invest any time or capital in a storage project. It's not feasible for them to begin that investment unless they know there's a path for them to finish. And then clarity comes into play. There has to be a distinct path to get through that regulation. So the regulations you establish can't be a maze or a mire to get through from point A to point B. There has to be a path to go through from permitting all the way to closure. Back on the certainty topic, there's a couple key points that establish a level of certainty that allows operators to consider moving forward. One of those is a firm legal decision regarding the ownership of pore space. So in North Dakota, it was determined by the courts that The pore space is owned by the surface owner. So we've developed our rules and regulations around that determination. There's also another key point that had to be addressed for industry to really consider moving forward with a lot of this, and that's that mechanism that allows us to release long-term liability. It's really difficult for an operator to commit to an indefinite period of financial burden. There has to be a mechanism for them once they've ceased injection or are done with their project to close that out and be released of that ongoing liability or that ongoing commitment. And so our rules allow for that after an appropriate amount of time and evaluation. Getting back to the clarity side of this, we have defined basically in the rules and regulations, it's pretty clear. There's a defined, we defined the requirements for the submission and review and approval of an application. We've established what those expectations will be once the operator is operating, right? Once they're injecting CO2, what do they have to do? Well, they have reporting requirements. They understand what their inspections will be when they'll be reviewed, and what we actually have a process in place where every 5 years they have to come in for a full review of their facility and make sure it's still operating as originally proposed. And then we also have in our rules and regulations a process for post-closure, site closure. We know the operator going into it knows what's going to be required at the time of closure when they abandon their wells, plug their wells, reclaim their location, how much they're going to have to monitor and review until the facility can be released at some level. So they know what those are, and it's all established in the rules and the laws from the get-go. So shifting gears just a little bit, what is a carbon storage facility? A North Dakota carbon storage facility is really, I'm going to try to summarize this in a couple ways, but it's this graphic on the right, the storage facility is a combination of where your stakeholders, your operators, your pore space owners, your geology, storage reservoir and your confining zones, your infrastructure, your surface equipment, flow lines, your wells, injection wells or monitoring wells, where they all come together in the storage facility. To kind of give you a frame on that, effectively what a storage facility, the definition of our storage facility becomes the extent of the land that has been affected by CO2, or that is storing CO2. So we have the operator model the extent of the plume during injection, and then post-injection, after they cease injection, how that plume behaves for a period of time after that, and we determine what a stabilized plume extent is. And so not just the stabilized plume, but any lands where CO2 is present during injection or during post-injection migration become the stabilized CO2 plume, and we establish an area around that plume, roughly about a half-mile buffer around that, and then they round that out to legally describable tracts of land. The CO2 doesn't exactly follow our lines on a map, right? So we have to line it out, and so it's legally describable and explainable in orders and whatnot. But that area that is the storage plume plus that half-mile buffer becomes the storage facility area, and it encompasses all the reservoir, the confining zones, all the wells, all the surface equipment are included in that storage facility. There's a, are you plugged in here? Yeah, it just went low. There's a dual process in place in North Dakota for the permitting. We actually evaluate the CO2 storage facility as an application in its own. We evaluate all the site characterization, being the geology, the geologic modeling, the simulation of the injection are all evaluated at the storage facility level. That storage facility can have one or more wells, injector wells or monitoring wells. We also review, the area review takes place, the evaluation of the area review and any corrective action needed, and assess financial assurances needs at the storage facility level. So we're taking that area where the plume is going to be present and all the requirements that go along with that placement of CO2 and assessing them as a whole, whether it's injected by one well or many wells, And so we're evaluating all of that at the facility level, and we issue a order that approves the storage facility itself. And then we turn around and have a secondary process where we review some of the material again and actually permit the wells, permit the actual CO2 injectors, the Class VI injectors, or any monitoring wells or subsurface observation wells. And during that review, we'll review the final plans for drilling and construction and the testing plans and make sure they're in line with what was proposed originally at the storage facility application term. Moving on, the storage facility has a pretty expansive life cycle. The process really starts 3.5, 4 years prior to whenever we get involved as a regulatory body. The operator begins the site screening and feasibility studies. They work through developing their geologic models and start the numerical simulations. At some point, they start having communications with us to let us know that they're proposing or intend to propose some storage facility in the area. We give them some guidance, work through a number of things with them. Eventually, they develop a draft application and they provide that to us, and we begin our review process then. We review the draft application, get it to a finalized state where we're looking at what we consider a complete application. And they have, at that point, they'll submit that as a final complete application. And then we'll begin the kind of formalized process. We'll start our internal final reviews. We'll have the DEQ evaluation. The Department of Environmental Quality reviews the application as well. Once that's done and they're satisfied, we'll docket for hearing. We have our hearing, we read our orders, and then operations can start, right? Then you're up in the green arrow here and you can begin operations. Operators may have some strat test wells in the ground where they're going to convert them. They begin injection, or they convert them to actual Class VI wells, begin their injection, begin their monitoring operations. As I mentioned earlier, there's kind of a process in place where once they're operational, every 5 years, we're going to review one of these facilities. That whole application basically gets reviewed. They actually continue their simulation with the actual volumes injected, history match that, compare that to some 3D seismic, confirm where the plume is going, and try to make sure that what was modeled is what appears to be happening in real life. And we review it, and we haven't done one of these yet, but we will review one and go through the whole process and make sure that this facility area and all that material we evaluate is still in line with what was previously approved. Eventually you get to the point where the operator is done injecting. They go to a post-closure phase where they stop injecting, plug their wells, reclaim their locations, continue some form of monitoring, and have another hearing to potentially release the site. Once the site has been determined once the plume has been determined to be stabilized, we can consider releasing that site. If we release the site, we actually take on the long-term liability for continuous monitoring on that as the state puts funds in place to allow for us to continue that operation as needed. Reviewing one of these storage facility applications, these are 3 bullet points, those early bullet points on the regulatory side, and I'm going to focus on one little red line here on that whole life cycle, but this one little red line of the Oil and Gas Division review is where a vast amount of information is reviewed and evaluated for correctness, appropriateness, reasonability, all kinds of things go into the evaluation, but there's a vast amount of work that gets done. These applications are 300 to 400 pages now. The first applications were around a 900-page application. My staff now helps quite a bit in reviewing all that. In fact, they do most of the legwork, but they do a great job in reviewing. The entire application includes all these different bullet points. There's sections for pore space, geologic exhibits, modeling, simulation, area review, storage agreements, testing and monitoring plan, post-site care, emergency remedial response, worker safety plans, financial assurance plans. There's a huge application, right? But a huge amount of work on our end goes into evaluating the geologic exhibits, the geologic model, and numerical simulation, all because it affects and it defines the area that the facility is going to be established and the area review we're going to have to evaluate. And so this is where you go, as geologists, you'll dive in a little bit here in that the information they collect to get to the point of providing an application to develop a geologic model. They start with existing legacy data. They take everything they can get their hands on, logs, any seismic they can get hold of. They will eventually probably drill a strat test well in the area over the lands that they intend to operate in. And they'll collect more site-specific information, all kinds of log suites, additional seismic if needed, core analysis, all with the intent of establishing what that storage reservoir is going to be, that injection zone, and what the confining zones, the upper and lower confining zones would be. They evaluate the mechanisms of confinement, the geochemical interactions, or the geochemical what the rock's made of. My brain just shut off for a second. They evaluate all that though, just to develop their geologic model. Then they take it a little bit further and they evaluate any faults or fractures or seismic tectonic activity in an area, any potential for mineral resource development in the area. That all has to go into their initial assessments. They take all of that information, which I've got summarized here a little bit, just snapshots of kind of the stuff that you would get. Some advanced log suites, they build their cross sections, they build their structure maps and isopacks. They review the seismic 2D, 3D as needed, develop parts of the application that summarize all that in bullet points and line items, so we can take a look at what the injection reservoir should be, what the confining zone should be, and support all that information. But they take all that geologic information, turn around and build a geologic model from it. That geologic model is an effort to take the very complex geology that you understand off of logs and seismic data and to try to simplify it without losing the variability that you have there. So it's largely a statistical process, but the goal is to come up with a reasonable and representative distribution of geologic properties. So they generalize the lithologies that they see in the logs. They take that distribution that they see within the wells or within the well or any wells in the area, off the seismic, whatever they can pull together. They generalize that lithology, statistically distribute those properties that they evaluate for those lithologies throughout a model area. And so they take all that information, and this next slide is a snapshot of the geologic model, the property of porosity within the geologic model once it's been imported into the numerical simulator. And so you see that they've taken higher porosity little pods are distributed throughout the edges of this, and that continues internally into the model in the area. You're just seeing the edges here, right? So once they have that geologic model, the next step is to numerically simulate what CO2 injected into that model will be. So they take and start simulating injecting CO2 into that reservoir. They vary different operating conditions. They change the times, the pressures, the temperatures, rates, and the composition, and run multiple models and kind of evaluate, try to get what is a representative result. They do sensitivity analysis where they evaluate which of those parameters is most sensitive to highs or lows. And then they try to fine tune what those values are, make sure those values within the model are as reasonable as possible to estimate. And ultimately, the goal here is to come up with what is that realistic plume migration. Where's the CO2 likely to go when you start injecting CO2? And not just while you're injecting that CO2, but after you cease injection, what is that CO2 going to do in the long term? And so it's the intent is to establish what that plume or what that CO2 is likely to do subsurface. So some of the results from the numerical simulation work, you get stuff like this, which is gas saturations. On the left, you see a north-south cross-section, and on the right, you see east-west cross-sections. But the top on each side is a simulation after, or a snapshot, or that cross-section after 20 years of injection, what the gas saturation would look like in the reservoir. The snapshot, or the cross-sections immediately below those are 100 years later, plume stabilization. After that plume has been identified as non-moving, it's essentially not migrating any further. And so you see that the concentrations has decreased around the wellbore, and it's spread out just a little bit more from what the injection ceased at when injection ceased. The diagram there in the middle at the top is a pressure front. After 20 years of injection, what the pressure increase around the injection facility might look like. Note that there's a red line here. I'm going to actually do this real quick and highlight this. It works. So this red line in here is after 20 years of injection. The orange line around it is post-injection plume migration, plume stabilization. A lot of the future slides that I'll show will have this outer boundary as the plume, stabilized plume extends. And so keep that in mind when I get to those other slides. But along with the numerical simulation of where the CO2 and the concentrations are likely to go, they do a lot of additional numerical simulation of the geochemistry, the geochemical interactions that happen in the reservoir. You have to understand what the effect of injecting your CO2 in your reservoir, as well as what its effect might have on your confining zones. If you're going to be injecting CO2 and it's going to dissolve your confining zone, you don't have much of a confining zone, right? So they do all, and I know these are really tiny, they're hard to see, but they're really tiny in the application as well. The gist is they come up with a distribution of CO2 throughout the reservoir. They come up with change in pH. They come up with the molar distribution of various mineral assemblages. They evaluate the change in porosity, both regarding dissolution of elements as well as precipitation of some elements due to the injection of CO2. And then ultimately they come up with a mass change. They take all these different properties, all these different mineral assemblages, and determine what's dissolving, what's precipitating, and evaluate whether that is good or bad for your reservoir, good or bad for your confining zones. All that work takes a fair amount of review, as I indicated. That's a lot of our focus when we're reviewing one of these applications. But the importance of it is it all goes into establishing what that stabilized plume will look like. So that purple boundary on there is the modeled stabilized plume for Red Trail Energy's ethanol facility, storage facility. And so, as I indicated before, that's the start, right? They model that, they get that area, that extent of that plume, and then they take and put about a half mile buffer around that and round that out to legally describable tracts of land. That's the white boundary. That becomes your facility area. From the facility area, you take and determine what your area of review, what area do you have to evaluate around that facility to evaluate whether or not storing CO2 in that area is going to be safe, it's going to stay underground. There's two methodologies for this, really. There's an EPA method, there's EPA AOR methods. Those work if you have either reservoir in equilibrium or underpressured reservoir. Unfortunately, in the Broom Creek in North Dakota, we have an overpressured reservoir. So using those two evaluation methods effectively ends up with an infinite area of review around one of these facilities. So we, not us, but the operators and the EERC came up with an alternative method that has been accepted so far of evaluating a risk-based AOR. And the details of evaluating a risk-based AOR are in each of the applications. Please feel free to jump on our webpage, dig up one of the applications and dive into how that's done. I'm not going to belabor the point here, but effectively what that risk-based AOR showed is that when you take a look at what the pressure increase will be in the reservoir over a distance from the injection site and evaluate what the potential pathway might be through a leaky wellbore, the percentage chances and the likelihood of affecting your underground source of drinking water is relatively minimal, and it doesn't expand all that far from the actual injection zone or the plume. And so they've opted to apply a 1 mile around the storage facility boundary, which is well in excess of what they're evaluating or what that risk-based AOR method is showing would be necessary. Within that area of review, as part of our review, we would look at any wells that have been drilled and penetrate the reservoir or the confining zones and try to determine whether they're properly plugged or if there's any pathways for migration of that CO2 out of the storage reservoir up into the underground sources of drinking water. That whole process that I just went through in reviewing the applications, and between when we get the draft application originally, when we dock it for hearing, and we might have an order out, is on average about 8 months, just on the regulatory side of the equation. It's taking about 2 months to review that draft application, each of the draft applications. There's about a 4-month period between when they submit their final complete application through our review process and when we can dock it for hearing. 45 days of that 4 months is actually a notice period. They're required to give 45-day notice. And so before the hearing, they have to get all that noticing out, and then we schedule the hearing out far enough that they can get that in place. So that's on average about 4 months of time. And then once we have the hearing, once we hear their testimony and allow a public to weigh in on stuff, we might have a period where we got to get some supplementals in. We evaluate, we write the order based on all that, and that's usually another 2 months before we can get it in front of the commission to sign. So total, from when we see a draft application to when we have an order out there approving a facility, is on the order of 8 months. So far, we're the only state primacy program to issue any approvals, and we've got a number of them. I'll get into the details in a little bit, but as I mentioned earlier, there's a lot of information available on these just through our webpage. Most of our publicly available communications are through the Class VI program page on our webpage. The state of North Dakota DMR webpage has a Class VI primacy program page, and on that page we have all the docketed applications. Any orders we have issued and any Class VI permits we have issued are linkable right there on that page. And so you can get at all the application materials for any of the previously approved facilities from that page. You can also pay attention to the advertisements through the local newspapers and or on our webpage when we docket hearings to look for upcoming hearings on any new facilities that might be in the works. But with that, I'm going to shift gears a little bit and go into the actual kind of review of our program, where we're at today. And so, as I mentioned before, it's a two-stage process. We issue storage facility permits and then follow that up with the applications to inject in Class VI wells or monitoring well permits. Today we have a total annual approved capacity of about 14,700,000 tons annually. Total over the life of all the projects we approved to date, on the order of 270 million tons, metric tons, and total sequestration over the life of all the projects. Most of them are projecting 20-year timeframes. There's one that has a 12-year timeframe. So our program to date, we have 6 approved storage facilities, multiple wells in a number of those. 2 of those storage facilities are active. We have 8 approved Class VI wells, 2 of which are active. Storage facility applications kind of pending. We don't have any waiting on order at this time. We have 3 in draft review, and we don't have any actual Class VI well applications in front of us at this time either. But we are anticipating something on the order of 10 to 15 actual storage facility applications in the, I don't want to say near future because these things take a while, but they're pending, they're coming. And a number of Class VI wells. We have 5 that need to be approved for already approved storage facilities. So when they apply for those, we'll review them and approve them. And then, another 15 to 20 or more wells associated with those projected facilities out there. Red Trail Energy was our first ethanol plant, the first approved storage facility in the state of North Dakota. We received that application in June of 21. 3 years or so after receiving primacy, and issued the approval of that storage facility in June of 22. Issued the approval in October of 21. They actually started injecting. The first injection happened in June of 22. And to date, they have put down 223,000, almost 224,000 metric tons to date over the year and a half that they've been operating. They're projected to reach 170,000, a little over 170,000 this year, with another month to go. Minn Kota Power Cooperative has 2 facilities approved in the center area around the Milton R. Young Station, power station. They have both a Broom Creek and a Deadwood facility permitted, storage facilities permitted in that area. They have not applied for injection wells at this time, but we did recently approve a permit for their monitoring wells. They're in the process of developing their capture technology to retrofit their power stations. That's the Broom Creek facility, and that's the Deadwood facility. The DCC West was actually the 6th application received. I'm putting it with the Minn Kota because it's immediately adjacent to the Minn Kota facilities. On this slide here, you see on the right-hand side is the original DCC or original Minn Kota facility. This storage facility was permitted immediately adjacent to that facility as backup to that storage, as well as accounting for the ability to potentially take a third-party source, whether that's from a Summit pipeline or another source of CO2. We worked through the process and approved the concept of approving a secondary source into those CO2 storage facilities. They had their orders signed most recent October 4th of 23. So that one just got its approval. Again, they haven't moved for applying for the injection wells, but there are a number of monitoring wells or strat tests that they've drilled related to these facilities. Dakota gasification was actually the 4th application we received immediately after those first 2 Minn Kota facilities. We had the Dakota gasification application. This is the DGC application up at Gila for the Synfuels plant. Currently, a lot of their CO2 goes up to Canada, to those CO2 fields up there. Those contracts are ending and they will start sequestering in the very near term. That facility was approved in January of 23. They are actively converting the wells that they have currently 6 strat test wells. They're converting them to injectors. They're going to have a rotation of injectors and monitors through the 6 wells. So this is a 6-well facility rather than a single well, but they're currently working through those 6, converting them to injectors. 5 of the 6 are ready to go. They're working on 1 more. They're projecting to start injection Q1 of 24. So probably in the next few months, they'll be online for the 3rd facility active in North Dakota. Blue Flint was our 5th approved facility in the state, but it is the second that has gone active. We approved this facility. It's another ethanol facility, a single well injector and monitor facility, but it was approved in May of 23, and they began their first injection really recently at the end of October. So far, I don't have formal numbers, so I don't have any numbers on my chart here to show you, but I got a sneak peek at their numbers, thanks Tammy. And they gave us, they're projected to put in, they should be around 15,800 tons as of about right now today. But they're projecting about 33,000 tons in the ground by the end of the year. Moving on from what we've got approved to moving into the pending stuff, we're actively reviewing 3 applications as I indicated. This is Summit Carbon Solutions. There have been a number of public information requests regarding these applications, so this information is out there in the public as well, so it's fair to present here. But these facilities, they're actually proposing 3 separate facilities, multiple injectors in each one. They've got 3 strat tests currently drilled. They have 3 strat tests permitted. Some of those strat tests will be converted into the actual injector or the monitoring wells, depending on how things work out. But these are the applications that are currently under the review process. I don't know if I can project. We'll have them out for docketing, but we're moving in that direction pretty quickly. So that'll be probably the next 3 that land for docketing and hearing and to be put in front of the commission for approval. What's coming on the train down the line? We have a number of anticipated projects. We know there's some interest by Harvestone. Harvestone is the operator of the Blue Flint ethanol plant. They have another ethanol plant, the Dakota Spirit ethanol plant, and or Great River Energy, which operates the Spiritwood station. We know there's been some 3D seismic up in that area. There's an interest in putting some sequestration on one or both of those facilities. We know that there's DOE grants related to Rainbow Energy, TC Energy, One Oak, and one of these direct air capture facilities that have been issued. Rainbow Energy is related to Coal Creek Station, doing CO2 sequestration there in the Underwood area. TC Energy and Marathon actually have a combination of grants. There's a DOE grant for a Liberty Carbon Management Hub and a DOE grant for a Heartland Hydrogen Hub. They're combining those. They're going to have them both in the Dickinson area. They're generally in that area, but functionally those are coming down the line towards us. One Oak has, again, a DOE grant for evaluating CO2 sequestration in northwestern North Dakota. This will be a little bit more complicated because we're in oil country. We're going to have to evaluate a lot more wells penetrations in the area of review, but it's coming down the line. We have two direct air capture facilities loosely on the radar, one being the Prairie Compass direct air capture hub. That one has DOE grant funding. It's proposed to be roughly in that same area as Minn Kota, possibly one of those third-party sources that might inject into the Minn Kota storage facilities or the DCC West facilities. And then there's another direct air capture entity, Retract. We know they've been doing some leasing in the Glen Ullin, Hebron area. So it's another facility that we're loosely aware of. We've had contact from landowners in those areas, asking questions and trying to get up to speed on what's going on with those facilities. So that's where that's going. With that, that's all I intended to talk about directly. I'm willing to try to answer a few questions here and there if you got them.
Is there restrictions on drilling an oil well between the outer review boundary and the inside, that 1 mile spacing?
So for those online, the question was, are there restrictions on drilling another well? The ask was about an oil well, but I'll just keep it to any well within the boundary between the storage facility area and an area of review or the outer boundary of a facility. And there aren't direct restrictions. The rules do not prohibit that. We have implemented field orders for these facilities, establishing a field order, basically a field order around these facilities in which we say we require that any proposal to penetrate those lands that are directly affected by capture in the storage facility area, that they would have to come in for a hearing for us to determine what the appropriateness, what the appropriate actions or restrictions on those wells might be. It is very feasible that you could penetrate one of these facilities with the right controls and understandings when you go to drill them, and or drill underneath them if with horizontal drilling technology if that was deemed acceptable. So no direct prohibition of it, but we're aware of the concern and the issue that might occur, and so acting ahead of time to try to limit potential problems. Anyone else?
What would this CO2 be used for in the future? If somebody wanted to mine it after 20 or 40 years.
So the question was, what would CO2 be used for if someone wanted to mine it after a period of time? I'm going to start my answer by saying the storage facilities we have now are intended as long-term permanent storage facilities. There isn't an option currently to go into one of those facilities and extract that. If someone were to go in to try to extract that, there probably would be ramifications with respect to federal credits that are basically what make these projects economic, the federal tax credits that they can get for injecting CO2. That being said, once there are, once the infrastructure is in place to get CO2 in an area, you can always move that CO2 to another point and maybe do enhanced oil recovery. You could take CO2 that was being delivered to a storage facility, and instead of injecting it in a storage facility, start using it for enhanced oil recovery, CO2, enhanced oil recovery, sweeping and pressure maintenance on oil and gas reservoirs. Maybe long-term things open up where they know there's some form of CO2 down there. They open up, you can go after it again. But by that time, in all likelihood, that CO2 plume has dissipated. The pressures have reduced. It'll be hard to bring it back to surface in any quantifiable, useful volumes.
So basically EPA is right. This is a waste product.
So the follow-up question, so EPA right in that it's a waste product? I'll answer that in this way. When you're taking CO2 and sequestering it with the intent of injecting it for permanent storage, it is intended to stay underground permanently. I got 3 hands. Who wants to go first?
These are from online, so we'll
Okay.
grab a couple online ones. If you're wrapped up.
With that one, I got
Yeah,
2
yeah.
more.
Okay.
The raised hand.
Okay, so someone asked 2 questions. So the first one is, are there complications if the CO2 plumes commingle, or do they need to be strictly kept apart?
So the question was, is there complications if the CO2 plumes commingle, or do they need to be kept apart? There isn't anything that prohibits a CO2 plume from interacting with another plant, with another plume, except for the physics involved. Really, once you start injecting, they develop their own pressure fronts, and you end up in a situation where the CO2 moving towards each other basically builds a pressure that it can't overcome. So effectively, you end up in a situation where it's not going to. Long term, once you stop injecting, and over an very extended period of time, you might see some slow migration into that. But we would have the facility areas are effectively established around what we expect that migration to be in the first place. So there shouldn't be really direct plume interaction at any point. But there isn't anything that directly prohibits it either.
Yeah. Yeah, we'll grab the other one online, and then the rest I think will be in the room. Last one was also, what type of long-term monitoring is the state looking at once the company has been relieved of reliability or liability?
So the question was, what type of long-term liability is the state looking at post one of these sites being released and us taking on long-term liability? The final answer is that hasn't been determined. We will have a hearing at the time of when we're considering actually releasing one. I say that now, but they have proposed, they have CO2. So these CO2 plumes in these annual reviews, they will shoot like 3D seismic. We have monitoring wells installed in the area. In most facilities have a monitoring well. So they'll start by evaluating those monitoring wells, determine whether the plume has interacted with those. They'll have 3D seismic that'll be evaluated. We won't release one of these plumes until we're satisfied that the plume is stabilized and we don't expect further migration. But once that's been determined, we will have the option to keep a monitoring well in place to continue monitoring it. We'll have the option, there's a fund that's set up that the operators will be required to pay in. Right now, if they're a North Dakota entity that contributes to the energy and or agricultural economy in North Dakota, they're required 7 cents per ton into that fund. And that fund is the trust fund that we can pull from to do long-term monitoring. So we'll have a nice fund established that we'll be able to follow up and do, if we feel it's absolutely necessary to do another 3D seismic shoot, there should be funds to do it. But final answer hasn't been determined because we haven't gotten to the release point, but it will be determined before we release anything. So.
These private entities that are implementing this, what is the financial structure that makes this financially viable?
So the question was, what's the financial structure that makes this economic, basically? Largely, it's federal tax credits. Their 45Q tax credits allow for, depending on what the source of the CO2 is. I'm going to draw a blank when I should have these numbers off the top of my head, but I drew a blank the minute I started thinking of it. Basically, whether you're sequestering CO2 directly, I think is it $80 per ton? 85, thank you. And then if you're using for enhanced oil recovery, it's 60 or 65? $60 if you're using CO2 for enhanced oil recovery. And so there's also a number, is it 120?
Direct air capture.
For direct air capture. So CO2 captured in direct air capture facilities and sequestered $120 per ton. So there's tax credits related to the sequestering or the injection of that CO2 and storing it that allows for these projects to become economically viable.
So basically, they're federally funded with borrowed money. Would that be?
I'm gonna opt to try to avoid answering.
Well, that kind of brings me to the next aspect of this is looking at the porosities and, and the formations and being somewhat familiar with volumetric, analysis. These locations look like pinpricks, and they look like really expensive projects. And can you cite any publications that discuss the basically the direct effect? I mean, if we sequester this much, it's going to lower the temperature by this much, or the amount of CO2 in the atmosphere per ton in sequestration has this direct relationship based on verifiable, repeatable scientific data?
So to try to paraphrase the question to some extent, what is the evidence out there regarding when a ton of CO2 is put in the ground, what effect that has on overall climate? That getting at the gist of your question?
Yeah, kind of a cost-benefit analysis, which I have yet to find the basis for.
And again, I don't have an answer for you.
Okay.
I can't say that there's been enough research or studies done. I'm definitely not aware of them.
It just strikes me as this is an expensive activity based on conjectural with borrowed money. I mean, the whole,
It's not borrowed money, it's your tax money.
well, it's borrowed from my grandkids.
Yeah.
Yeah.
Okay.
So anyway, okay.
Yeah.
What's this direct air capture? How does that work?
Okay, so the question here is, what is direct air capture and how does it work? And so direct air capture is basically putting up facilities to process the air in the area and to pull CO2 out of the air and to turn around and inject that. There's a number of processes being worked out. The one that I think someone has presented on us involves processing it using some steam to help knock out and dissolve the CO2 from the atmosphere. But effectively, it's atmosphere captured CO2. So removing it directly from the atmosphere instead of taking a source that's emitting CO2 because it's burning some resource, you're taking it directly out of the air and processing it, and then sequestering it directly.
Do you know if the technology's there yet on that? You think you'd rather do a coal stack or something?
Right. So the question is there, is the technology there for direct air capture? It's moving in that direction is my understanding. There's been a lot of smaller scale tests. They're working on upscaling to the industrial size. There's a lot of interest. There's at least multiple entities that are moving in that direction with the intent of potentially putting something in place. So I believe it's been proven to some extent. I don't know if it'll get to that full scale or not, but it's moving in that direction.
So a little off topic, more of a regulatory question. I recall there being some questions about flow lines versus pipelines, and pipelines have become a little bit controversial and a big deal. And so where do flow lines stop and pipelines begin?
Okay. So the question kind of on the regulatory side regarding pipelines and transmitting of CO2, where do flow lines versus pipelines, where do they start, where they end? The flow line, we have a definition of a flow line. We establish that definition when we approve a facility. It's typically with respect to something like an ethanol plant where you're injecting in close proximity to your source. That flow line is from your capture facility to your injection facility, and we regulate that. That's part of our storage facility. When you're talking about an entity that is moving their CO2 a significant distance away from their source, in fact, DGC, Dakota Gasification, theirs isn't too far, but they have opted to permit PSC transmission pipelines for their CO2 from their facility to the edge of the pads where they have their wells planned, and the flow lines start at the edge of their pad to the injection well. So those transmission lines largely will be anything that's transporting a significant distance will be a transmission line, PSC jurisdiction. If it's on site or on facility or directly adjacent to, related to transmitting it from that point to the actual storage facility, those will be flow lines. One more in the back.
Apart from the size of the reservoir, what other factors limit the amount of CO2 you can put into a facility?
So question is, apart from the size of the reservoir, what other factors limit how much CO2 you can put in a reservoir? And it's all of them, but largely it's pressure, right? We don't allow them to exceed a pressure that would fracture the reservoir or fracture the confining zones. And so the volume and the rate at which they're putting that CO2 underground will determine the pressures that the reservoir is seeing. And so that's really the large determining factor around it. Injected slowly enough over a long enough time, you can probably continuously inject for a pretty extended period of time. Anything else?
I know it's 1 o'clock, but
That
to
time?
follow up on Steve's question about the economics of it is pretty much solely tax credits. You also have these companies, Google, they want to say they're carbon neutral, so they add up their carbon footprint from their data centers, and they plant that many trees, or they pay someone to plant trees, or whatever it is for them. Do you know, I mean, not your, what you spend your time on, but, is there private commercial money maybe coming for this sort of thing? Like, well, it's easier to just say, we paid for 100,000 tons of CO2 to be sequestered, and we're carbon neutral. We're Amazon, that's.
So the question, I'm going to attempt to again paraphrase a lot of stuff there, but effectively, is there other economic drivers for sequestering CO2 related to large emitter point source or emitter entities that want to lower their carbon footprint? And yeah, those markets are probably developing. We don't have like a cap and trade set up right now. Canada has that kind of model in place. I don't know where we end up in the long term with sequestration in the States, but functionally, when an entity wants to offset their carbon footprint, they can start investing in something like the ethanol. Say an entity that uses ethanol wants to reduce their carbon footprint. Well, they can buy the ethanol from Blue Flint or Red Trail because it has a lower carbon footprint than the ethanol coming out of a neighboring facility. And so it is along those lines. It can incentivize an entity to start putting that CO2 on the ground in a number of ways, but probably kind of where you were going, a true cap and trade type situation that doesn't quite happen yet, but it's, wouldn't be surprised if it landed there at some point.
And a clarification, my question was about, is there actually a capital basis for doing this also? I mean, these fellows that are Amazon and Google that are planting trees and everything, is that PR virtue signaling, or is that actually protecting the environment? At what cost? And is it a this is a good idea because for every dollar we spend, we're gonna keep the Earth's temperature down 0.0001 degrees centigrade. So I just don't see much actual capitalism involved in any of this, to tell you the truth.
And
So
I'm gonna default again, but
Yeah.
we're well outside of my expertise in talking economics and all that. So
well, the question is out.
it's out there, yep, and it's something that's fair to ask. I'm just not the one that can even come close to answing.
I was just engendering.
Probably got to get AI involved. And start having that process.
I don't think they want to get AI involved in this.
All right. Good. All righty. Well, thanks everybody.